me change this a little bit. And let me prepare everything. Hopefully I got everything. Yeah. All right. Hello, everybody. So welcome to Discussion C. And today we'll talk about K nearest neighbor and SVM. But yeah, I just put in the kid next door because they have a K and D, but technically we're learning KNN. Haha, get it? I hope that I'm not too old, that you guys don't understand the Cartoon Network reference. Anywho, all right, let's go into the materials then. So a little reminder that so far we learned linear regression and logistic regression, right? So linear regression, you try to capture the data, while no, it should be this one. Yeah, linear regression, you try to capture the data, while logistic regression, you try to draw a decision boundary, and it will be the shape of it. It will look something like this, right? So yes, we learned logistic regression, which draws a line to separate data into each group, and we try to classify the data. But the problem with that is that what if your data is not Flintstone-nearly separable? This should be linear. What if the data is not linearly separable, right? So because the data, typically it looks something like this, that you draw a line, right? And then you separate the data between one class and another class. But if the data looks like this, then the logistic regression might not be an ideal solution for how you classify the data into multiple class, right? And the data is like spreading all around like this. And that's gonna be another algorithm which we use to classify data called K nearest. It should be K nearest neighbor, or we just call it KNN for short. And KNN, how it works is normally you just choose a number, which is the K, and that's where the K come from. It's just a random number that you pick, or you might have to analyze data and then pick the number of K, right? And then you find its K nearest data neighbors, duh. And then after that, you use majority vote to classify the data. I love democracy. Yeah, let's see, like for example, in this case, right? You have a K. So suppose you have data that you try to classify whether this yellow square, is that one supposed to be for class A or class B, right? So you put in the data and then you specify. So let's specify that, okay, let's specify K to be 3. So then you then find its nearest neighbor. So just use all kinds of distance formula, and then you keep track of each data, right? And then see which one gives you the closest one. And then from those closest neighbor, you just do a majority vote. So see if which one has the highest frequency when you're counting the nearest neighbor. So like for example, you set K to 3 and then you count it. Okay, for 3 nearest neighbors, you have 1 of class A and 2 of class B. So you're gonna go with these two, which is class B. Right. But then what will happen if you also increase the K? So if you increase the K to 7, in this case, right, you also keep track of where are the nearest neighbors. So you have these 4 and then these 3. Then you do the majority vote, and then you're gonna say, okay, majority of the K is gonna be 4. So we're gonna pick this one, which is class A, because they have 4 neighbors in the area, or between the nearest neighbor area, right? While the class B has 3. So you can kind of see like if you change the parameter, which is K, and then it's gonna the data, the yellow square is gonna be changed into like either 1 or 2, but generally you would do all kinds of cross validation, right? And then try to see which one is the supposedly correct one for you. But that's also like another data analysis part for you. Yeah. But that's the That's the general concept for the k nearest neighbor. Any question? Yeah, disclaimer, I don't think today I'll go into like there are all kinds of math equation. I probably talk about like how it works on a surface level and a little bit of example on how it works, but not too much of the math equation. Question? You good?
All good, I think.
Neil unmuted a little bit, but I guess that's an accident. But yeah, put in the chat or unmute. Feel free to. Otherwise, I'll move on. Move on then. Let's see. Yeah, but there, but there's a problem with the real data set, right? So in data set, there's always gonna be some kind of outliers, which is some data that is not supposed to be within its own particular position or range, right? So KNN may classify it incorrectly because there are some kind of, so it's supposed that there's also outlier in here, like this one. You also have this triangle in here, right? And then you set k to 7, so then the new boundary is going to be probably going to be something like this, for example, right? But in general, we should ignore this one so that it gets the correct one, which is this this four star rather than you have 3 stars and then 4 triangles, right? And that's going to be our problem. And we also have another algorithm or another model to tackle that issue, which is support vector machines. And yes, that one I'm going to work on example. So let me add a page of that and see. So for example, for this support vector machine, and let me write that down. Example. So I suppose your data looks something like this along the line that look like this, right? And then we have the right one is just something like this, and probably go with that, right? That's going to be one class of data, and then another one we can go like this blue, which is another class. Yeah, right. I guess like if you use common sense, then you try to classify the data, right? So you try to also draw the decision boundary so that it separates the data. So you probably say like yes. So then you draw the decision boundary like at this point. And yes, that's basically that basically it for the uh, the lower level concept of support vector machine is that you draw a decision boundary. That and some terminology. So when you look into the decision boundary, there's going to be some kind of distance between this decision boundary. So there's going to be some distance between decision boundary to your data. So it's going to be on the both side, right? And these two they are called margin. So let me also write down. Let me pick another color. See here. This distance called margin. So margin this can be distance between I could call it decision boundary, but I'll say threshold for now. Threshold and a data from each class. Yep. And yeah, you could say like yes, but we can take since that we can technically also draw a decision boundary in like this one too, right? That also works because yeah, that one also correctly classify the data. but we can we can make we can make it to be more generalized, quote unquote, to by setting it to be uh, right at the middle between two classes. So that's going to be our ideal decision boundary. So the goal of this is going to be, you want to maximize the margin, because you don't want to have one margin to go like at this position, and so like this test of one and then another one has like four, this and four, right? You want to go like each side 2.5 and 2.5. And yeah, oh, by the way, this one, this whole model or whole algorithm that you try to draw a decision boundary and you maximize the margin, this one, this is called support vector classifier. So this one is support vector classifier. So from the name of it, it's some terminologies too, and I think you have to memorize it. Just know like where the name come from. Support vector refers to the data that is that become the first data that for you to draw the margin to the threshold or to the decision boundary. So this support vector, and same thing as the other class, support vector. Yeah, and that's the concept of a support vector classifier. But as we refer back to the problem is that real data, there are always outliers, right? So let's also look at another example. So, but what if the data look like this? The data looks like this. So gonna draw a line here, and we have this similar data to the above one. So something like this, and we have that. Right, suppose our data looks like this, but somehow this one technically is going to be our outlier. So let's just assume this one is outlier first, right? We don't You don't have to care like, oh, but can we like remove it out or anything? Suppose we don't know, and then we just know that it is outlier, and then you run the whole process as the same as you do with the support vector, right? You draw a decision boundary that maximize the margin, or basically draw it in the halfway line between two support vector, right? So halfway line. So then your decision boundary is going to be like this. This one is going to be at this position, right? But we know that this is our outlier. So this decision boundary is not ideal, right? So you want to, in ideally, so if you goes back to the above one, you also want to draw around at this position, right? So you're gonna, this one is gonna be ideal line, ideal decision boundary. So we're gonna stick with this, the ideal decision boundary, by allowing some outliers to be on the other side, right? Because we have a red class and then blue class, and then let's say we use the same logic of support vector classifier, and this one you say, so recap, we say that the position of this support vector is going to be the one that you start drawing the decision boundary in between, right? So this red one was your support vector before, to allow some outliers. Let's say, let's ignore that point to be our, let's not use that point as our support vector. Let's use the next one as our support vector instead. So this one was before, right? And then we just change it to this one to be our support vector instead. And we kind of like ignore it. So I put in some like maybe some kind of X in here. So just X and then just a check to be our support vector instead, right? So if you decide to ignore this one and use this one as a support vector, and then you say, okay, then now you're gonna have this red one as your support vector and this blue one as your support vector, and then you draw a decision boundary in between them, which is gonna give you the ideal decision boundary, and it also benefits you by ignoring the outlier. And this whole model is gonna call soft support vector classifier. So I'm just gonna go call it soft SVM, which in a nutshell, it allows some misclassifier data, some misclassified or outlier data. So this is going to be the concept of support vector classifier. Right? So you basically classify data by draw decision boundary, but you may have some outlier. If you have some outlier, you soft classify, soft SVM, SVC, yeah. And that's something that people come up with. And yeah, got good question specifically. And yeah, if you want to like, so the process of like ignoring one data to be your outlier, that's also a part of your hyperparameter too. So you will have to choose by yourself whether you which data, how many data points that you're gonna ignore or ignore it to be on the other side. Hope that kind of makes you kind of familiar with this algorithm a little bit. But yeah. Otherwise, I'll move on. I guess let's move on then. Yeah. And feel free to ask me any question. And yeah. So we kind of solve the problem of outlier already, right? But then what if the data is still linearly inseparable, right? So because we have data that looks something like this, and then we draw a linear decision boundary. So which is we draw a line, right? But we can't draw a line for this data, right? So you're gonna go like this, or like this. Yes, you can draw and you can also draw a circular decision boundary that also technically works too. But we also have another techniques that calls kernel. So the kernel can hopefully solve you the linearly inseparable data for you. So which in this case, the kernel, how it works, that it's going to transform data into another dimensional. And hopefully you can draw a decision boundary so that you separate the data. So yeah, and I come up with an analogy so that hopefully you guys can understand it better in a better way. So let's say we have this analogy, right? So let's say Elon Musk, he's trying to solve his problem of going to the moon, right? And so he basically trying to solve problem of like do some kind of calculation of his Tesla driving on the moon, right? But he's if he's gonna calculate on the about the how to drive of the driving on the moon, so he has to convert everything from Earth scale to the moon scale, right? So then that works, but how about another way, which is you send everything to the moon, and then you basically calculate everything on the moon, since it's already like works on the moon scale, rather than you staying on Earth and then you convert everything to moon scale by yourself. Just send everything there, and then let them do the calculation over there. And that's the analogy of this one, which is support vector machine. So support vector machine, right? Which is so as I recall, we learned about the support vector classifier, and there's something called kernel, which is you transform the data into another data with different dimensions or different coordinate, I would say. Yeah. So it's gonna be uh, support vector classifier plus kernel, and that gives you the support vector machine. Right? And I can also write down the analogies. So you want to calculate data by the moon scale. So uh, send everything to the moon, and calculate that. And that's the analogy of what you do with support vector machine. And you transform that analogy into this, so it's gonna become something like this. So you stay within the world of say you are now in the world of just X, right? And then you transform the data by using kernel. So you have kernel. That's a bad handwriting. Let me rewrite that. Kernel. And by using kernel, you transform the world of X into a world of X square. So then you can draw the decision boundary in a better sense, like that, right? Or it can be plain, but yeah. So instead of like you can't draw anything here, you transform it so that you can draw the decision boundary on another dimensional, or on a higher dimensional. Like from 2D, you just change it to 3D instead and draw that from the 3D. Make sense with the idea? Thumbs up, question, concern, comment?
I guess I have a question. Like, how would you go? Like, what does the kernel do to allow you to like convert it to x squared?
Yeah, so they are totally different kernel function. I don't remember on top of my head. I think that's like x of, and suppose like you have the idea of x and y, right? You can go with like it's gonna be x square, x times y, and then y square, something like that. Like say if you have point of 2, right? So you transform that into x square. It's gonna be 4 x by x is gonna be 4, and then y square is gonna be 4. So that's like 2D. So 2D to 3D. I think that's one of the example, but
Okay,
it can also
that makes sense.
yeah, it can also look
Is there like a way to determine which one to use, or does it kind of do that for you, the computer?
uh so far for me I just let the library do it by default, but you can also pick up some of the function too. So I can also like double check SVM and function. That this look up this looks ugly. Also looks ugly. I don't like that. I guess you could go with something like this. Yeah, you have position of x1 and x2. You just you can like multiply them together. That's like your linear kernel function. You can go with polynomial and Gaussian, sigmoid. And for the scalar, they also have provide the parameter for you to give so that you can change it. You can try to change it and then see how it works with your test error or train error. So scalar and SVM, I believe, or SVC, yeah. So yeah, they provide all this kernel for you as your parameters. Kernel, linear, polynomial, RBF, I'm not sure what that is. Yeah, sigmoid and pre-computed. So you will have to change it and see if which one works for you. Yeah. Clear?
Yeah, that was perfect. Thank you.
All right. And yeah, that's pretty quick for today's discussion because that's pretty much the whole concept of how you use k-nearest neighbor and support virtual machine. Right? So to recap, for linearly inseparable data, so basically you can draw a line to separate data. You can use the KNN or SVM to separate data and classify data. Right? And k-nearest neighbor, find test data of k-nearest neighbors. Yes, so you input the test data and then you find its own k-nearest neighbor, or like which is like say k is equal to 3. Right? So you find 3 nearest neighbor and you vote for the majority class. And then that's going to be your class of that particular test data, because you don't know what class of test data belongs to first. Right? And support vector machine, it draws the decision boundary and it calculates decision boundary by transforming them into a higher degree or higher dimensions. Yeah. Hope that helps you understand like the logic of that, and the math behind it is kind of a little bit ugly, not gonna lie. Yeah. So I don't want to touch a little bit more. Not that I didn't learn anything about the math of support vector machine, but anyway, yeah. So yeah, hope you learned something today. And let me see, it's only 1:30. I can't like take a break or go with the homework. We can take 10 minutes break. Yeah, let's take a 10 minutes break and then we can come back to do some other part. We also provide you a collab for k-nearest neighbor and support vector machine, but I don't know if that's like something for you that interests you, or would you rather go for homework and group discussion? But we can talk about it after the break. Yeah, let's come back at 1:42 then. Break. 2. All right, it's already 1:43, so I think I decided for the structure of after this, we're gonna we're gonna do some collab on how and see the coding of the uh, key nearest neighbor and support virtual machine, and then I'll address some issues with the homework too, and maybe I can talk about my anime recommendation and the logics behind it. So hopefully you guys can have a better understanding. And maybe I'll after that we just turn into office hours and you guys can work on homework or work on your group project. All right. Let me change my screen then to uh, the edge. Let me see. I have that. So yeah. I don't think I'll. I don't think I'll write down like everything. I'll probably just goes into it. I'll probably goes into more like the function and then goes into the full implementation and then try to explain what each section is doing, and maybe hope you guys can probably look into the function name later and try to understand like what are some the things that you can change, the parameters that you can change, and what are the useful libraries. So I'll send you in the chat the first link, which is just a template for the collab of k-nearest neighbor and support vector machine. And please save a copy of that, all right? And don't edit it on the collab. And I think that, yeah, but I'm gonna also look into the solution, which is the one that already implement everything. Because I feel like I don't want to spend like the hour write down everything. And also I have you guys can try to figure it out and then look at the solution as your uh, reference rather than struggle like all the way and then kind of waste time, I guess, to do something else. Yeah. But yeah, that the second one is the solution, which is the page that I'm on at the moment. And let's talk through then for the this collab logic, right? So in sklearn, this one, when you look into sklearn, the first cell is basically imports the data from sklearn, because in sklearn they already have their own data default data sets for you to play around with. So this one is gonna be data set, and then just load one, which is the wine data set, right? And then I can run it. Oops, yes, kid, don't forget to save a copy. I almost done that. Haha. Uh, yep, so you basically load the wine data set into this wine variable, and then let's look into it. Wine.head. Let's see, you have that. Uh, interesting. Now that I have to uh, also fix this amongst yourself, among this. Let me see what's the data type wine. Bunch. I should try pandas and port pandas as pd. Pd.data frame wine. And give me 1 sec. Data frame wine. What is data frame? I think it's data frame. Yeah. Haha. Interesting. Now that I'm gonna have to debug on here. It's okay. You guys gonna learn how can we debug Google. Right. Let's see. Sklearn. What's the error says? So if you ignore that, and then you have wine.head, and I think Sklearn dataset has no head. So basically you load data and you try to use pandas. It has no attribute. So load arrays by default. Yeah, that oops, I got a chat real quick. It's in worksheet already. Doing that on purpose because it was usually used in PRI. Good catch, hopefully. Wait, let me double check. That does seem to work. Yeah, haha. I'm so stupid because I didn't read everything. But that's a part of learning. I will hope you guys also learn along with me. But yeah, that's uh generally, yeah, that's one thing. If you load the data, you might have to either try to convert it to pandas or you you have to work with their own data set. But since we are familiar with their pandas, hopefully you guys can try to use that. So you have wide features. It's already have their own. So yeah, the sklearn data already has their own attributes, or so you can just simply access from their own attributes. So this one's is wine data set. Just go with their wine feature names. And target is target name basically just see what are the class that they are classified as. So this one you have all of these target and then class 0, class 1, class 2. Right? And yeah, I think that's anything worth mentioning. So you have 140 178 data, and then you have each data has 13 column, which is 13 dimensional. And we're gonna see how it goes in here. And yes, you perform the trend test split, and again this one just use 0.2, but you can use test size as like 0.3, 0.1, doesn't matter. Yeah, you might have to try to like cross validation. And yes, this is the how simple is that, right? You learn all kinds of math, and then when you use the library, simply just import the library, create its own object, and then you feed that data into your data, feed that model into your data, and then you predict it, and then bam, it's already everything will works out for you, right? And then you say you run the score, and then give out the score for you. How easy is that? And yeah, there's going to be some parameters that you have changed. So this one say that we specify the n neighbor, which I can check to share my screen do something to this. We take that and just to recap, we have that. To recap, we have k nearest neighbor, which we have to specify how many nearest neighbor that we're gonna pick up, right? So example has 3 and 7, but in this case for our collab, we just specify in this one the n neighbors to 5. And if you still don't know like what are things that you can change, oh, of course, Google it. Sklearn nearest KNN, and then it will tell you everything on what are the things that you can change it. So like in nearest neighbor, some algorithm, but if you don't really know, you can just leave it as default. That's also fine too. But maybe you can change it to hopefully get a better accuracy. But anyway, yeah, you do k nearest neighbor, we fit the data, and then you print out the score. Bam, done. So easy. Yeah. And this cell we want to see. So before we change it, the nearest neighbor, we set it to 5, right? We can also iterate through every possible nearest neighbor, and then try to use that, try to find the one that gives you the best performance. That also works for you, for you too. So this one we only set from case from 1 to 15, and then we do the same thing. Create the model, feed data, and then print out the accuracy. But this one we're gonna plot it instead. So we print out, plot it, and then bam, this is gonna be your graph, right? And you can kind of see like which K will give you the best one. But it may be different from yours because of how the random number works on your environment. But yeah, this is, but we can just leave that at the moment and just see that from this graph I can kind of see that, okay, maybe KF12 is going to be good for us in this case. So let's pick with that. And this one just used some kind of math operator to like give you the K, the best K, because this one is called max accuracy. So the accuracy is gonna have all kinds of Y value like 0.62, 0.5, 0.55. You just pick up the max accuracy. So this one 0.75 and give you a K of 12. And yeah, that depends on how you like organize the data and then pick out the max accuracy. So that's like the, yeah, and everything that is the K nearest neighbor and what you can do within 5 minutes of work rather than do everything by hands. Yeah. And move on to support vector machine. It's also the same thing. You don't have to implement like a check if there's any point or something. Just import it and then run it. Right. So you import a support vector machine and then you use SVC, which is the support vector classifier. Right. You fit the data and you predict it. Bam, done. So easy. And so easy that I feel like, yeah, we probably don't need to like maybe work through or some stuff. But anyway, and yes, so as a reminder, support vector machine has its own kernel, and there are many different kernels that you can like transform data. And these are some of the lists of the kernels that we also went over a little bit. And in this case, you can also try something like this too, which is you try to see if different kernels will provide you different accuracy and just try to figure out which one gives you the best performance. Right? So you basically create a support vector classifier object and assign kernel as one of them. So you look through one of them and then try to see which one gives you the best accuracy. So you run it and see that in this case, linear gives you the best accuracy, right? And again, you do all kind of math operation, call it max, and then I give you the best linear is 9.972, and we're probably gonna pick the linear in this case. And that's it for today's collab. See everything that we just learned, like 12 pages of the discussion. You can kind of say like, I don't care about it. And let me see, where did I put that meme? I think, yeah, read the math behind machine learning, but you say import it, done. That kind of works, yes, but in some way you might have to read the math behind it so that you know you can adjust the parameter that works well for your data set. Something for you to be aware of. But otherwise, that's like the whole collab, and maybe you guys can look into it and from the link that I sent you and see that maybe that's something for, and see that if the support vector machine is something for your group or not. If it is, maybe you can like try to, is there something you can pick out of from this collab? And other than that, we can move on to the next part. Let's see. Yeah, for homework 2, there's some Yes, for you guys, for those of you guys who watch the recording later, sorry, my internet got cut out, but for the homework, be aware of the homework part 2. Homework 2 part 2, there's some syntax error, and Edwin already do the correction on Piazza. If you have any question, please look into the Piazza. And other than that, I don't think I have anything else for those of you who watch the recording later. Maybe have fun recording, and don't forget to like and subscribe. Check out Patreon. But anyway, that's all for the discussion for the recording. Yep, and that's it. And I'll work with the rest of you guys after this. And